All right, this is lesson 4, angles and a point. Example 1, we are going to set up and solve an equation to find the value of x. Notice our little box here. So this is our 90-degree angle. So I'm going to put that in right away. This is 3 angles. They form a circle. So it adds up to 360 degrees. So I have 123 plus 90 plus x, and this all equals 360 degrees. So next I'm going to add I'm going to add 123 plus 90, and I get 213 plus x equals 360. Next I'm going to subtract 213 from both sides. And I get x equals 147 degrees. Example 2 says, 4 rays meet at a point, at a common endpoint. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve the equation to find the value of x. Find the measurement of BAC and DAE. So BAC is right here. Oops, sorry. And then DAC, or DAE, I'm sorry, is right here. And then remember, our 90-degree angle is right here. So I'm going to put that in, and that's right here. Okay? So here we can say that angle BAC, angle CAD, angle DAE, and angle EAB form angles on a point and add up to 360 degrees. So now when I add these together, I have 204 plus x plus 90 plus 5x equals 360 degrees. Well, first thing I want to do is I want to combine my like terms. So I have 5x plus x is 6x, plus 204 plus 90 is 294, and all of that equals 360 degrees. The next thing I'm going to do is I'm going to subtract 294 from both sides. On the left-hand side, I have 6x left. On the right-hand side, when I subtract both of those numbers, I have 66 left. So when I divide both sides by 6, I have x equals 11. But I'm not done because it's asking me to find the measurement of BAC. So the measurement of BAC, which is x. So that measurement is 11 degrees. Then it's also asking me to find the measurement of DAE, which is 5x, or 5 times 11. which is 55 degrees. Okay. My next example says 5 rays meet at a common point in a complete sentence, describe the relevant angle relationship in the diagram, set up and solve an equation to find the value of A. Well, you got to be careful here because we have a situation where this right angle here overlaps, and it overlaps this right angle here. So you have to be very, very careful. So first, let's write our sentence. We have 2 right angles. We have 2 right angles. Well, we don't. So we have angle A, angle 143 degrees. We have our right angle, angle 90 degrees. And we have an angle of 90 minus 21. And they form angles on a point and add up to 360 degrees. And the reason that this angle is 90 minus 21 is because, as I said, the one overlaps the other. So this right in here cannot be counted twice. So we have A plus 143 plus 90 plus 90 minus 21 in parentheses equals 360. Now you can do this one of 2 ways. You can either put in the 90 minus 21 in parentheses, or you could subtract the 90 minus 21 and simply put in 69. Either way is perfectly okay. But I'm going to fix this and say, not fix it, but I'm going to subtract it now. So 143 plus 90 plus 69 equals 360. Now I'm going to combine all of these, my like terms. So that plus the 90 plus the 143 equals 302 plus A equals 360. And then I'm going to subtract 302 from both sides. So I have A on the left side. On the right-hand side, I have 58 degrees. For example 4, again, we have to write a complete sentence. So I have angle BAE angle EAD, angle DAC, and angle CAB form angles on a point and add up to 360 degrees. Now let's put this into an equation. So we have 12x And remember, we have our little box here, so this is 90 degrees. We know that. So we have 12x plus 90 plus 3x plus 60. And all of that equals 360 degrees. So let's put our like terms together. So we have 12x and 3x, which is 15x. We have 90 and 60, which is 150. And all of that equals 360 degrees. So now what I'm going to do is I'm going to subtract 150 from both sides. So now I have 15x, and that's going to equal 210. And I'm going to divide both sides by 15. When I do that, I get 14. But I'm not done because it wants us to find the measurement of CAD, and that's the only one it wants us to find. So the measurement of CAD, which is this one right here, which is 3x. So 3 times 14 is 42 degrees. Our next example we are finding the measurement of FAE, which is right here. Oops, sorry. FAE, which is right here. And CAD, which is right here. But if you notice, if you notice here, this is not angles on a point. I'm going to erase this again. And I'm going to show you that we have this angle here and we have this angle right here. So if you look very, very closely, these are actually vertical angles, and this little box is 90 degrees. So actually, these can be set equal to one another. So I can actually say 2x plus 90 plus 6x. And all of that's going to equal 170. Because notice there is nothing here and there is nothing here. So that can't help me. It's not angles on a point. Okay, it's not angles on a point. They're vertical angles. So now I can add 6x and 2x, and that's 8x plus 90 equals 170. So when I subtract 90 from both sides, I have 8x equals 80. I can divide both sides by 8, and x is going to equal 10. Well, the measurement of FAE, which is 2x, equals 2 times 10, which is 20 degrees. The measurement of CAD is 6x, or 6 times 10, which is 60 degrees. Our next example is one that is the same thing, okay? It says list the relevant angle relationships in the diagram. Okay, to list this, these are vertical angles. and they are equal. Okay, and how I know that is I have this right here, and this is 90 degrees right here. And I also have this right here. Because remember, nothing is here and nothing is here. So these are vertical angles. So I can set them equal to one another. So if I set these equal to one another, I have B plus 95 equals 90 plus 80. So I have B plus 95 equals 170 degrees. So if I subtract 95 from both sides, I have B equals 75 degrees. And that ends this lesson.